Hello everyone, this video is about integration by substitution. So the steps are: we define u, follow the instruction. In the question you will be given specifically what substitution you have to use. Find du dx and replace everything in terms of u to in terms of x, or cancel out everything with x, so you have to use just u. And then you can substitute back to x if you use indefinite integrations, but you can also change the terminals or the limits of integration if it's definite integration. So for example, here using u equals sine x, find the integral of cos x over sine squared x dx. So u equals sine x, the du dx is therefore cos x, the derivative of sine is cos, or we can say dx equals du over cos. So just like algebra, we can switch the dx and cos x here, and so the integral becomes still in cos. We have cos x here. We substitute the sine with u, so sine squared u squared. The dx is du over cos x. We substitute, but as you can see, cos x divided by cos x, they cancel out. So now we have integral only in u. So if the integration is only in u with respect to u, we can just differentiate. So we get u to the power of minus 1 divided by minus 1, the usual rule integration. So we have minus 1 over sine x. This is the final answer, and you can recheck. If this is the y, then the y prime is exactly the same as the integrand here. Another example, u equals 1 plus x. We find this. Define the u, find du dx, and we get dx equals something. And you can do this here. If u equals 1 plus x, of course x equals 1 u minus 1, and minus x equals 1 minus u. 1 minus x equals 2 minus u. So we can replace 1 minus x with 2 minus u, and we replace 1 plus x with u, and we replace dx with du. So we have 2 over u minus u over u, and for 2 over u we get ln modulus u, and for the minus 1 we get minus u. And if we replace back with 1 plus x, the u is 1 plus x, we get 2 ln 1 plus x minus 1 plus x plus c1 constant, so 2 ln minus x minus 1, or we can just say 2 ln minus x. So this minus 1 plus c1 is just another constant, we can just call it c now, and you can recheck by differentiating. So 2 ln 1 plus x becomes 2 over 1 plus x, and minus x becomes minus 1. And if we simplify, or if we manipulate here, 1 is 1 plus x over 1 plus x, and so we get 2 minus 1 minus x, which is 1 minus x. So in the end we get exactly the same as the integrand here. Another example, find the integral, this time definite, 2x e to the power of x squared plus 1. Define the u, we have the u equals this, d dx we differentiate, so dx equals this. And now we also want to change the terminals or the limits of integration. When the x equals 1, the u is x squared plus 1, so 1 squared plus 1, which is 2. And when the x is 0, we plug in 0 here, we get 1. So now we can change the terminals 0 1 to 1 to 2, and we can substitute the u. Actually it's supposed to be in red. We replace the x squared plus 1 with u, we replace the dx with du over dx, and turns out dx over dx cancel out. We have only this integration, and the integral of e to the power of u is e to the power of u. Just plug in 1 and 2, we get this final answer. Now alternatively, You can still use the original terminals from 0 to 1, but after you find the e to the power of u here, you're gonna have to switch the u back to x, because the terminals we are using 0 to 1 is for x, not for u. So if you plug in 1, plug in 0, you will get exactly the same result. By changing the terminals or not changing the terminals, you get exactly the same. And last one, we have u equals ln x. Use the substitution, and ln x all squared divided by x. You can just find the du dx. The derivative is 1 over x, so the dx equals x du, cross multiply. If the x is from 1 to e, the u is from 0 to 1, because u is ln x. So ln e is 1, ln 1 is 0. And now we replace everything, the x cancel out, and we can integrate. We get this, and this is the final answer. Or you can also substitute the u back to ln x, and now you can use the terminals in x. The original terminal in x is this, from 1 to e. Plug in and you get exactly the same result. That's it. I'll see you again next time.